All right, for our lesson today, we're going to talk a little bit more about sine and cosine, but specifically I want to go over some of the relationships that sine and cosine have inside of a right triangle. So I want us to just fill out these first couple of questions because it's a little bit of review here, because we're just setting up sine and cosine of different reference angles. So using that triangle over here on the left, if we were to set up sine, and you're still thinking about your SOHCAHTOA, we would be setting up on sine of A first. And so if I was going to set up sine of A, using my SOHCAHTOA, I would be doing opposite over hypotenuse. So if A is your reference angle from the big A, your opposite side would be little a, and your hypotenuse would be C. So we would write this as A over C. Okay, now if we were to do sine of B, so right underneath that, sine of B would be switching our reference angle up here, and we would go opposite over hypotenuse, so that would be B over C. Okay, so now if you think about this to yourself, for numbers 2 and 4, I want you to write out what would cosine of B look like and what would cosine of A look like. So what would cosine of B be set up as? Okay, A over C. And what would cosine of A look like? Good, B over C. So like if you're looking at these two fractions, what do you notice about them? Yeah, it looks like sine of A and cosine of B were set up the same way, and sine of B and cosine of A were set up the same way. So we're using opposite reference angles there, and also we have opposite like trig inverses. Like if we're considering sine and cosine opposites right now, okay? So that's kind of this connection that we want to focus on today between these two things. Now, a couple of things that we can observe. If you're looking at your triangle over there on the left, how much do you know angle C would be? Yeah, that little box tells you that it would be 90 degrees, right? Okay, so then angles A and angles B, those are kind of separated there. But if those are put together, okay, so if I were to add A and B together, how much would they have to equal? They'd also have to be 90, right? Because in a triangle, we know that the three angles should add up to 180. And so if I know that one of them is already 90, then I know that the other two, regardless of what their measurements would be, if I put them together, would also have to equal 90, okay? Okay, so now that we kind of see these relationships between these angles here, and we're kind of reviewing what we know about what triangles and their angles do, there was a term that we used to represent when two angles added to 90. You guys remember what that term was called? It was a vocab word that we talked about a while ago about angles. They have like a special name when they add to 90. Yeah, complementary. Okay, so number 7A, when they ask what term could be used to describe A and B together, we could say complementary. Ooh, I'm running out of space. I apologize for my handwriting here. My pen's being a little bit weird today, so I'm trying to just make the best of it. Complementary. I'm just going to abbreviate for right now, but you guys know that that should be complementary, okay? So then if we're looking at A and B, they're asking for 7B to say express angle A in terms of B. So if you knew how much B was, what could you do to figure out how much A is? Yeah, you could take 90 minus whatever angle B is. So the measure of angle B. So whatever you know B to be, whether it's 30 degrees, 20 degrees, 50 degrees, you would just take 90 minus that, and that would get you what angle A is, because you know that they should add up to 90 degrees all the time. Okay. So when we look at these two things, they're asking for number 8, what observations can be made regarding the sine and cosine of angles A and B? So those two angles that are kind of that we started out with up there. We are recognizing that if you have the sine of an angle, so if I had the sine of angle A, that would be equal to the cosine of angle B. And that same thing is happening up above if I were to switch A and B around. So I could also write this as the sine of B is equal to cosine of A. So I could say that instead, but that still would be a true statement. Okay, so what I would like you guys to do for a second here is on number 9, there's this really big table down here. And there's a lot of numbers, okay? I know it's a little overwhelming to look at this all at one time. I'm going to give you guys like 3-ish minutes here maybe. I want you to take a look at this table, and I just want you to write down anything that you notice. If you have like a highlighter or something and you want to highlight things that maybe are sticking out to you, I want you to just take a minute and look at this table and see if there's any connections that you can make between the numbers. Okay, so I'm going to give you like 3 minutes to do that. Okay, did any of you notice anything about the chart? Is there anything that maybe stood out or like connections that you were able to make between the columns of the numbers? You're noticing some of them are the same. So can you like give me an example of a pair maybe? And I'll see if I can maybe get it highlighted. If my pen works for me here, I'll see if I can highlight it. Okay, so you said like 10. Oop, no, there we go. Maybe that'll stay. Okay, 10 matched up with 80. Yeah, like the numbers in the columns there, they seem to be like the sine and cosine, not so much the tangent, right? But we're looking more so at the sine and cosine right now, that those seem to be the same number, but just reversed order. Okay. Do you notice others that do the same thing? Like give me, if you're seeing the same pattern, give me another pair. Okay, 20. Ooh, I don't want to highlight that one. 20 and 70, you're saying? Oops, sorry, that's a little sloppy. Good? Yeah. Keep going. Find some other ones for me. Just name a couple more. Okay, 45, it lines up with itself, right? Because it doesn't have anything on the other side. Good. Yeah, if we chose something like really random, like maybe 17 or even like maybe 27. What's 90 minus 27? Yep, so that would line up here. Okay, so all of those pairings that we kind of looked at, the numbers in the degrees column, what are they doing? Yeah, if you put them together, you get 90. Like the 10 and the 80 that we started with, 10 and 80 make 90. 63 and 27 make 90. 20 and 70 make 90. Now, 45 we said would go with itself, right? Because 45 plus 45 is also 90. Yeah, good. All right, so those are some relationships that we can kind of make and see why these sine and cosine are going to be equal to each other. So now what we're going to do, if you guys turn your page over, is we're going to kind of explore some of these relationships here and solve for something that's missing in one of our problems. So on these first couple, they're giving you one of the angles in either sine or cosine. And so to find the other angle, we have to basically use that relationship that we just saw in the chart. They should add to 90. So we want to subtract from 90 to get to the other side, okay? So if I have cosine of 63, you would take 90 minus 63, and that would give you how much your angle is. So what would that be? I think it's pretty close to the one that we just did, right? Isn't that the one that I highlighted? Yeah, so that would be 27. Okay, what would the next one be? Good, 56. And then the last one? Yeah, 45. Okay, good. Now, the next set are a little bit different. They're giving you these quantities. Now, we weren't putting those angles equal to each other up above. They were maybe equal on our charts, but I don't want you to assume then that that means that the actual angle measurements are equal unless it was 45, right? That was the only time that we saw that it would be the same on both ones. So in this case, when I'm given expressions that involve like a variable or something and we need to solve for that, what you're going to do is add the pieces together and then set it equal to 90 degrees. Okay, so you're going to do 2x minus 1 for this first one. You're going to add it to 11. You're going to set that equal to 90. Okay, so now what I would do is solve for my x, and I'm going to start by combining like terms. So I see that the negative 1 and the 11 can go together, so that would be 2x plus 10 equals 90. And then what would you guys do? Okay, and then if you divide by 2, you get 40. Good. Now, sometimes when you solve, you may not get a whole number. There's times where decimals are going to show up or something like that. So just be aware that while it might be working out for me right now, it's not necessarily always going to be the case that it does that. Okay. So on the next one, let me just draw a line here to kind of provide some separation. If we go to the next one, we would start it out the same way. We would add the pieces together. So x plus 5 plus 4x plus 10 equals 90. I ran out of room there a little bit. Okay, so if we put our like terms together, how many x's do we have? Good, and then we have numbers together would be 15. Good, equals 90. So go ahead and take a second and finish that one off on your own. So what do we get for x? Good, 15. All right, why don't you guys go ahead and try to do number 15, that last one, by yourself. I'll give you some time to set it up and figure it out. Okay, I'm going to go ahead and set this up. So I would have added my pieces together. 1/2 x plus 24 equals 90. Oops. Okay, so when I add the 1/2 and the 1x, I'm just going to write this as 1.5x. And then I would have moved the 24 over. So I would take 90 minus 24 to do that. And so this would equal 66. And then I would have divided by 1.5. And so you should have gotten 44 for your x. Okay, any questions on those last few?